Hi everybody, welcome to another video in Business Calculus section 9.5 Basic Differentiation Properties. On the previous section we learned about derivative, but just the definition, and we certainly can use the definition to find derivatives, but it will take a lot more work. In this section we learned the first rule about the derivative, the power rule. But first, let's look at the notations of derivative. There are a lot of different ways we can write derivative for the function y equal to f of x. The normal way, whenever possible, we'll just denote by apostrophe f prime of x and then y prime of x into the function y equal f of x. The prime sign denote the derivative. Or we can write dy over dx. The reason we do that, remember the definition of derivative. Is that, and here we have the difference in the values of the function, or the difference in y, and at the bottom is the difference in x. So that's why we write dy over dx. So y is the dependent variable, x is independent variable. So there's actually more notation for derivative, but here all we have. And sometimes if x is clearly the variable we're talking about, we can just say y prime would be enough if we understood the variable is x. Right, so that's the notation of derivative. Now on to power rule. Power rule actually refer to this one, but we have the constant function rule. If y equal to a constant, then derivative of a constant is equal to 0. So we say we write like this. Derivative of a constant is equal to 0. Now, the real power rule. Power rule refer to the power of x. So we have x is the base raised to some power, n is the real number. Then derivative is that real number times x to the n minus 1. Or we can say just derivative of x to the n is equal to n times x to the n minus 1. So we take out the power, and original power is subtracted by 1. So that is the rule. So we use that instead of the definition. In that case we can find derivative a lot quicker. But since we talk about the power rule, we need to know the properties of the exponents, namely also the powers. So let's say where b is the base, and define b the base greater than 0, and also we don't want it to be 1, because if b equal to 1 raised to any power is equal to 1. So it doesn't matter, so it's just a constant. So that's why we do not have the base equal to 1, and base is positive as well. Right. So with that we have these properties. 1 over b to the m is b to the negative m, or we can also say 1 over b to the negative m is equal to b to the m. Loosely speaking, anything at the below the division line, if we move that above, I can just say that over 1. If we can also write like that. But if we move something from the bottom to the top, from the top to the bottom, the exponent will change the sign. So that's the same. Let's say cross the line, the division line, change the sign. change the sign of the exponent. So we can represent that as a power, because in order to use the power rule, we need to have in terms of a power, right? So I have to write x raised to some power. That is the rule, right? So that is the, we'll take care of the reciprocal. By the way, if we say 1 over x squared plus 5, we cannot move the x squared from the bottom to the top because of the plus. But if we have 5x squared, then yes, if it is multiplied, we can move this to the top and have 1 over 5x to the negative 2. So when we have only the power of x at the bottom, it could be multiply, it could be divide. But if there's a plus or subtract, we cannot move just the x, we cannot move just the 5. We're just going to leave it like that. But if there's a multiply, we can move the term from the bottom to the top and change to the negative exponent, right? Now, so let's take care of a reciprocal function or in form of the rational function. Now, if we have a root, now notice that here we have the m is on the power and n is on the index of radical. So power on top, root at the bottom. I can also write like this. As long as we have m will be the power either on that power or on that power. Remember, power is on top, as n on the index of radical will be at the bottom. So power stay on top, the root is at the bottom. And after that, we have the properties to combine the exponents. When it's multiplied, we can add the exponent. When it divide, we can subtract the exponent. And power to another power will multiply the exponents. Right. So after all of that, now we're ready to use the power rule. Right. So first, if y equal to x to the third power, so and the power rule say take down the power and original power minus 1. Whatever you do not just write equal like this and then apply the power rule. Take down the 3 and the original power minus 1. If you write like that, the rule is correct. However, it is wrong because y is the function equal to x cubed. This is the derivative. So we have to write something to denote that this is the derivative. So yeah, just like that. That's the power rule, which gives us 3x squared. Right? Take down the power, original power minus 1. And so that is the function. And that's a derivative. Next, what is this? Y equal to 1 over x. Remember, we can use power rule, but it has to be as a power of x raised to some power. We don't have that yet, so we'll rewrite the function. So we still haven't done any derivative. I just rewrite the function. I can say that x to the first power, because x to the first power is still x, so there's nothing there. Now this x from the first power stay at the bottom. If we move to the top, we change to negative exponent. So x to negative 1. And then we can take derivative. the derivative say we take out the original power, original exponent, and the original exponent subtract 1. So that is the power rule. So that gives us -1 is still just negative. -1 and -1, that's -2. Right, so that's the derivative. Now if we want to rewrite this, remember negative exponent, we can move to the bottom. There's still the negative sign, right? So move to the bottom. Become x squared. X to -2, move to the bottom, becomes x squared. And we have to write something on the top. So we have the fraction. So just put 1 on the top. So we have the fraction. Right? So that's the power rule. Need to be in the power. Then we can use the power rule. Right. Now we have the cube root of x. Now let's just rewrite again. We have the cube root of x. By default, we can say it, x to the first power is just x. That will be equal to x raised to the 1/3. Once again, power on top, root at the bottom. Right, now we have the power. We can use the power rule. And the power rule say, by the way, let's just use the proper notation. The prime of x equal to. Now the power rule say, original power. Take it down. And original power minus 1. Right? So 1/3 minus 1 is -2/3. So if you want to full details, 1/3 minus 1. We have to find the common denominator. 1 is 3/3. So when we combine fractions, we have to have the same denominator. And then we have 1 minus 3 on the top, which is minus 2/3. So -2/3. Right. Of course, if you use a calculator, 1 divided by 3 minus 1. If you want to change this to fraction, hit the math. And then you can change to fraction. Right, now next, so that of course on the test that is acceptable answer, but if we want to rewrite it, remember negative exponent, if we move to the bottom, it becomes positive. Right, cross the line, change the sign. Then we can also rewrite this as power on the top, root at the bottom. Right, we can write the answer like that. So that is 1/3 times cube root of x squared. Right, so of course any of this is acceptable answer, which is the derivative of cube root of x. Right, so that's pretty much the power rule. You can apply the power rule to any power, but it has to be in the power form. In that form, or this, or this. Now, to apply more rules, we have some. This is not really a rule, this is just a properties. It says that if there's a constant in derivative, we can take it outside, and then derivative of the sum is the sum of derivative of a difference is the difference of derivative. Now if we look at this, and when we find the power rule, derivative, the power rule, we just find derivative of all the powers in polynomial like this. So all of that. Now if we take derivative of x to the fifth, that would be 5 x to the fifth minus 1, so that's the power rule for that. And then for x squared, we're going to take out the 2 and the original power 2 minus 1, and then there's 1, derivative of 1 is a constant, derivative is 0. So we apply the power rule for individual terms, and then the rest will stay the same. We have the 3 multiply to it minus 4 multiply to it, and then plus, right? So we have 15 x to the 4th minus 8 x plus 0, so pretty much that, right? So we applied the power rule to just the power. The constant multipliers will stay, the minus will stay. However, this only works if there's a plus or minus in the middle or the constant. Remember, this is very important. If we have like x squared times x squared plus 1, we cannot just say derivative of x squared is 2x and derivative of this is 2x. There's a multiplying here. That will not work. If we have the combination of exponent, by combination I mean only minus or plus, subtract or addition, subtraction or addition, or maybe a constant multiply to it, that's where we can just split and do powers individually. Not like that. This would be wrong. Right, next we have the powers here, and that just minus, so subtraction is perfectly fine. So we'll take derivative of this. The 2 is a constant, derivative is equal to 0, and derivative of this, take down the power and original power minus 1. So that's why we have derivative. Remember, make sure you write the notation properly. And then the minus 4, just want to say the minus 4, right? Now if we write like that, what is the sign between here? Remember, this is negative 4 multiplied to it, so that should be multiplying to it. That to be more precise, just put the parentheses here. Remember, this is negative 4 multiplied to it. It's not subtract negative 3. Subtract 3, that would be wrong. So negative 4 times negative 3 is 12. X to negative 4. If we want to move the x to the negative 4 to the bottom, become positive. On the top will be 12. Right. So yeah, the power rule, to take derivative of each power. Right, now derivative of this. So clearly we can check derivative of x to the 4th. We can check derivative of x and x to the 5th, but that would be wrong. Remember, we have to rewrite this. So we have x, everything will be on the same level. Not like that. So we need to take care of this first. Right, so by default, we can say this to the first power. X to the first power is still x. Now, 3x to the 4th, that's perfectly fine. Remember, I'm not doing derivative now. I just rewrite the function. X to the first, move to the top, become x to the negative 1. Then we said there's a 1 here, right? If you want to, we can just say 1, multiply to it. Perfectly fine there. X to the 5th from the bottom, move to the top, becomes x to the negative 5. And there's a 2 times it. Right, we have to write like this, so we can use the power rule. The power rule only apply x, everything on the same level. There's no multiply or divide of the terms. Don't just apply the derivative to x squared here using the power rule for that. That would be wrong. Have to be in the power. So that's why we review the properties of the exponents before we done the derivative. So let's simplify this one more step, and then we take derivative. 3x to the 4th minus x to the negative 1 plus 2 x to the negative 5. Now we take derivative. The notation. Right, x to the 4th. That will be 4x. Sorry. Let's just keep all the training wheel here. Right, so power rule for that. Now power rule for x to negative 1 is negative 1 or just negative. Then x to negative 1, original power minus 1. And then we take the derivative of this. Negative 5 x original power minus 1. Original power is minus 5. Right. And then there's a constant multiply to it. So there's 3 multiply to it. And there's a negative. So in that case, I have to put the extra parentheses here. And then there's a plus 2. And again, it's multiplied to it. So make sure there's a parentheses. Right, so that's how it works. Now we just need to simplify this. That will be 12x cubed. Negative and negative, that turn to positive. X to negative 2. And that's negative 10 or minus 10. X to negative 6. Right, so that's the derivative. And everything here will be the function. So we write the function so we have the powers. Then we can take derivative. Now we have negative exponent. If we want to, we can move to the bottom. But to me, it is just a lateral move. We just rewrite the function. We haven't not doing any derivative on this step. Move that to the bottom, become positive. Right. So in order to use the power rule, it have to be in the powers. We can have the combination of the powers. By combination, I mean the plus or minus in the middle, or the constant multiply to it. Right. Next, we have this. So, remember, the root, we can rewrite that. So that will be as the power. Then we can use the power rule. So I'll rewrite 3 and then square root of x. Now by default, x to the first power is still x, so I can put 1 there. And the square root, to go without saying, square root is a 2. We don't need to write a 2 if it is a square root, but it's a 2. It's understood to have be a 2 there. Right, now this I just rewrite the 4th root of x cubed. And then square root of 5. Of course I can write the square root of 5 to the first square root of 5 to the first, or 5 to the 1/2. I don't need to do that. Why? Because square root of 5, there's no x in it, so it's just a constant. Derivative of constant is 0, right? So I haven't done any derivative, but I just want to rewrite it. Now we have x, power on top, root at the bottom. Power on top, root at the bottom, and then the constant. Right, now we take derivative. Because we have the power of x, that's constant, and then combination, there's a plus in the middle, and multiplier. So all of that should work now. So power rule for this, check down the 1/2, original power 1/2, subtract 1, and then plus, check down to 3/4, sorry, take it, the plus, do that later. I just do all the power. 3/4, then x, original power minus 1, and then the square root of 5, that the constant derivative will be 0. Right, and then there's a 3 constant multiplier, which is fine. There's a plus in the middle, and the plus in the middle. Right, so I will rewrite this as 3/2. X 1/2 minus 1 is negative 1/2, plus 3/4. X 3/4 minus 1 is negative 1/4. Right, so 3/4 minus 1, have to write the 1 as the common denominator, and we have the common denominator. That gives us negative 1/4 and 0. So that's it. Now both of them have negative exponent, we can move to the bottom. I said we don't need to do this step because derivative like this is perfectly fine with me. And then plus 3/4 x to the 1/4. And finally we can rewrite x to the 1/2 as x to the 1/2, right? Power on top, root at bottom, and then plus 3/4, and then x to the 1, root, power on top, root at the bottom. So which is the square root of x and the 4th root of x. 3/2 square root of x plus 3/4 the 4th root of x. Right, so that's what we have. So just apply the power rule to individual terms. Make sure we can only have plus or minus in the middle or a constant multiplier. For something like this, we cannot do that. We cannot just go ahead and find derivative of x cubed and then derivative of x squared. That will be wrong. Remember, we can have the combination of the powers rule, and by combination I mean add or minus in the middle or constant multiplier, not divide like this or not multiply like this. So for something like this we have to do something. So there's two ways to take care of this. Number one is to have just x squared at the bottom. If we move to the top, that becomes x to negative 2, x to negative 2, yes. So x to the bottom, move to the top, becomes x to negative 2. And then we say, what do we have? X cubed and x cubed plus x. Well, that is just multiplying to it. Right, move the x squared from bottom to the top, that becomes x to negative 2, and now we do that. Now, by default, we can say this to the first power. Right, we still cannot use the power rule for each term yet, because they're still multiplying here. So we have to take care of this multiplication before we can go ahead to the power rule. Right, so for this, we'll distribute the x to negative 2 inside it. X negative 2 times x cubed plus x to negative 2 times x to the first. So that gives us x to negative 2 times x cubed. When we multiply, we add the exponents, negative 2 plus 3 and negative 2 plus 1. That gives us x to the first and x to negative 1. Right, I said that is not the derivative. I just rewrite the function so we have the powers. There's actually another way to do this. This is a rational function. We can actually split this into x cubed over x squared, add x over x squared, default that to the first power, right? So we split the top. We can split the top, cannot split the bottom like this. Only can split the top, and the bottom will stay the same, right? Now we divide top minus. When we divide, we subtract the exponent. So that gives us x to the first plus x to negative 1. And that's exactly what we have. So either way, we have that. Then we can take derivative. Power rule. And power rule. Sorry. In the next section, we don't have to write this every single time, but this is the first time we see the power rule, so I just write all the steps. Original power minus 1, and there's a plus in the middle. So that gives us 1, which is, we don't need to write the 1, x to the 0 power, plus, actually that subtract x to negative 2. Right, of course we can stop there, but remember we did review the rules of the exponent, right? To 0 power is 1, so we write x to 0 power is 1. And then this, if we want to move to the bottom, become positive. Right, or you can just say 1 minus x to negative 2. Any of this. All of them are acceptable answers. Right. Next we have square root of x times x plus 3. From now we know we can write square root of x as x to the 1/2. But then we still have the multiplying here that we have to take care of before we apply the power rule for each term. Right? So let's just rewrite square root of x. By default, we can say x to the first. Square root is 2, and then this is multiplying x plus 3. Alright. Now, of course, we multiply it out, but before that, let's just rewrite x to the 1/2 using the power rule. Remember the power rule: power on top, root at the bottom. Now we just multiply them out. Remember, writing this is actually, if we just rewrite a function right equal like this, perfectly fine. But when we start using the power rule, that is derivative, we have to write something else that equal to it. So that's the proper way to do it, proper notation. Right, now we multiply it out. Multiply to x, then plus, and then this just multiply by 3. By the way, by default we can say it to the first power. Alright, now again, this is the way we combine. When we multiply, we add the exponent, divide, subtract the exponents. So that's exactly what we do. So multiply, add the exponent, and so we just have this. One half plus 1 is 1.5 or 3 halves. Plus 3 x to the 1/2. Now we take derivative. We have x to the 3/2 minus 1. Right, and then x to 1/2, take down to 1/2, and the 1/2 minus 1. That's a plus 3. Multiply to it. So you have 3 over 2. X to 3/2 minus 1 is 1/2. Plus 3 over 2. X 1/2 minus 1 is negative 1/2. Right? So and we can take down the x to 1/2 at the bottom if we want to. And we'll rewrite this as the power on the top, root at the bottom. Move this to the bottom, become both 1/2. By the way, we don't need to write the 2 or the 1 here, so we just say 3 over 2 square root of x, and 3 over 2 is square root of x at the bottom. X to 1/2 is square root of x. When we get used to it, we can just say, when we say x, square root of x, not x to the 1/2. And also, when we see that derivative of x, it's just 1. So when we get a lot more practice, we can get to the answer quicker. And I emphasize that the answer can be any of this form. So it takes a lot of practice, but the power rule is very simple. Just take out the power and original power minus 1. We can do that to any combination of those powers. By combination, I mean we have plus or minus in the middle, or there might be a constant multiplied to it. It cannot be multiplied, it cannot be divided. Right, and with that, we finish section 9.5. As always, thank you for watching, and see you in another video in Business Calculus.